MSA, or Measurement Systems Analysis, helps to make sure those measurements are accurate. And that's what this video is all about. So first, let's talk about why MSA is needed. So process improvement is driven by data. So our measurements of our process have to be accurate. We have to be able to trust them. So what if we spent $100,000 to fix a critical process and then realized we relied on bad data? We took measurements that weren't accurate at all. It's going to be a serious problem. So what's important here is to not blindly accept our measurements. We have to confirm them. And so measurement systems analysis is going to help us do that, to make sure we're getting good measurements. So now let's talk about an overview of MSA. So measurement systems analysis helps us to identify variation caused by our measurement tools and methods. Now, as we take measurements, as we measure things, there's influences that affect those measurements that we need to acknowledge. And so the measurement that we get, the reading that we get, is going to be affected by those influences. So here are some of those influences, and I'll use an example of tuning a guitar. That's a process, tuning a guitar. Now, the actual output, the measurements you're going to get, are going to be affected by the person, the operator, turning the pegs, and then the procedures they're using. So who's actually tuning the guitar, and what process steps are they using? And then it's also going to be affected by the gauge, or the tuner they're using, and the reference value in that tuner, and then the environment as well. So if someone's trying to tune a guitar and the baby's screaming in the background, that may affect the reading that we're getting. And so we have to think about these influences and how they affect the measurements we get. Now we have a few objectives of MSA as we carry this out. We want precision, to get a consistent measurement each time, and then we want accuracy, the average measurement to be close to the reference value. And the way to kind of think about this is visually looking at a target. So precision is you've got sort of all the points clustered together, even if it's maybe not close to the reference value. Accuracy is, on average, you're close to the reference or the target you're seeking. If you get both of those things, you get these measurements close together and close to the reference value, whatever that is. So you're seeking for precision and accuracy.
Let me assure you, I know a few things about this. Generally about engineering, measurements, and this topic in particular. So much for my credentials. So leave all that aside. Let me take it one more step further. This is our request to you to get things in order. Please make continuous monitoring possible. It is not that difficult. For the very basic measurements that you have done and qualified the system, that much can be done very easily. Some VOCs also can be included. Want to try? If you find it difficult, please hand it over. Just say, we don't know how to do that. Just admit it. It's okay. Alright? And I will show it to you. It can be done. If you feel like it, you can refund me the costs later. How about that? See, there's no need for pride. Lives of people are at stake here. So this is not a time for pride and games. Let's take it in the real sense, do something sensible, and get over with it.